always changing the interface for the users. So this builds a number of limitations in the user's freedom, because you always have to have a guy running next to him, and it's eliminating a number of side effects like the precision of the user's input, or disruptive effects like sunlight or whatever, which you can't measure with these two. That's why we decided to follow a mixed fidelity prototyping approach, where you use digitalized versions of the paper screens and bring them on an actual target device, and they're displayed there, and the phone reacts on the user's behavior itself. To develop mixed fidelity prototypes for mobile applications, many research teams use simple software applications which are running on a desktop computer, and in which you can use a mouse to sketch your application, or you scan in sketches you made on paper with a scanner. And a pretty well-known tool is this denim tool of Peter Newman, or another one of this Portuguese group around Luis Dessar. What we don't like that much about this idea is that this link of the paper sketching and the adding of the functionality is a bit lost, because you do this paper sketching normally directly on the paper, and further you always pretty much have one in control over a desktop application. Like there's one having the keyboard and the mouse in his hand, and it's controlling the work, so it's not that usable for group work. That's why we decided to use our unobtrusive tabletop, because you can directly sketch your paper there, sketch your paper sketches there, and in a native environment for collaborative design, because you this is like the normal working sphere when you meet up with teammates and discuss ideas. And since we use an overhead projection system, this leaves us the opportunity to embed physical objects into the work as a kind of bridge between the real and digital world, as a kind of multi-point, which is in our context with the paper piece itself. The core of our system is a Java application which is controlling a point gray fly cap over a Java native interface. This camera is searching for barcodes on the table, which are printed on the paper screens used for the development. And moreover, it controls a regular Canon DSLR camera over TCP layer, and which is used to make these high resolution versions of the sketch interfaces. The output of our application are a number of JPEG files, which are these digitalized paper versions, and some XML, which is building the functionality the developers described about their sketches. These files can be transmitted onto a target device, and in the actual testing setup, this is communicating with the server, on which is running a quite simple script. So whenever the user is taking an action, like clicking a button or whatever, this context iPhone would ask the server what it should do next. And on the server, the script that's runs on the server is pretty much as simple as a script the team member would play a computer in a regular paper prototyping session would have to have in mind or written out in front of him. I'll now show you some short video clips so that you get a better impression about how our system looks like. As I described to you, we use paper sheets with unprinted barcodes that you can see here, and do your sketches on these paper sheets. We didn't make it yet to implement our finger tracking system, so we still have to use a mouse to define functionality on the paper sketches, which is done here by using a mouse to drag them there. And yeah, so now I just do some relocations, which is not that amazing. So you end up with your, sorry. Why is this not playing? Oh yeah, okay. So you end up, sorry, the controls we just placed are linking buttons, which are meant to be used to result into a change of the screen on the target device, and you can use our system to define these interface passes, which help the developers to have a good overview how the system would work and like see it in front of them on the table. Since the place, this is a quite regular table of the size you have in front of you. Since the size of the table is always limited, we built in addition a heap building tool, a stack tool, where you can like overlay interfaces, and the tool is helping you to get to not to lose the overview in showing you what happens. The digitalization of the pictures is done in the following way. You select a screen that you want to digitalize. Here there's a little first step of an interface sketch on it. Then the system will take a photograph, and you can then substitute this screen which is painted on with a blank one, and the system projects the picture just made on the screen, and you're now free to add new content onto this picture. And if you digitalize it again, as I do now, the system calculates the information together, and you end up with a new interface, which is giving you the opportunity on the one hand to have a timeline of your interface creation, that you can redo changes, and yeah, that's actually the meaning behind it. Yeah, and like our project is still not there yet. We still have to do an actual user study in the first step with designers and ask them for their thoughts about it. As I said, we wanted to introduce a finger tracking system, and we plan to use our table to use it to implement multi-touch gestural input, because on most of your cell phones, like on your iPhone or Android phone or whatever, finger motions are used to control an application as well, not just buttons. And so we could use this table to define such functionality. And another thought we are having is that we substitute this functionality definition process with an optimized sketch recognition, so that when you draw a button in a specific way, the system recognizes the functionality automatically.